We are going to use power series to compute this limit. The limit as x goes to 0, sine x minus x plus 1 over 6 x to the third power all over x to the fifth power. We are not going to use L'Hopital's rule. We will just use the power series expansion for sine x, center d at 0, because we have x is approaching to 0. And this is how it goes. Let me first put down, this is the same as the limit as x goes to 0, and let me get a big fraction bar ready. We have to remember what is the power series for sine x. First, remember that sine x is an odd function, and the first term for sine x is x. And then sine x and cosine x, they are both alternating. The next term is going to be minus, but then for sine x, it's the odd function, right? But then for sine x, it's the odd situations. We have the odd power over the odd factorial. And let me just put down the first full term for sine x. The next one is plus x to the fifth power over 5 factorial, and then minus x to the seventh power over 7 factorial. I think this should be enough for sine x. And put down dot 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 because it keeps on going forever. All right, and then we have the rest, which is the minus x plus 1 over 6 x to the third power. All this over x to the fifth power. And now what? Is there anything we can cancel out on the top? There are two things. First, this x and this minus x cancel each other out. Secondly, this is what? This is minus x to the third power over 6, technically, because 3 factorial is 3 times 2 times 1. This is 6 in the denominator. This and the positive version cancel each other out very nicely. And is there anything else we can do? Let's take a closer look. This is the limit as x goes to 0. On the top now, we have x to the 5 over 5 factorial, and then all over x to the fifth power. So of course, we can cancel all the powers right there, right? For the first term, we will have 1 over 5 factorial after we cancel this out. And then for the next term, we'll have the minus. This is x to the seventh power over x to the fifth power, so we have x to the second left. And then we still have the over 7 factorial. And then dot, 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 right? So now, we are going to take the limit as x is approaching to 0. But then for all these terms here, they all have an x. When we plug in 0 into all these terms, they pretty much will just become 0. The only term that will be left is just the 1 over 5 factorial. And 1 over 5 factorial, it is 1 over 120. And that is it. This is the answer.
That's it.